Morning. Today in this class, we will study about important chemical conversions of carbohydrates. The first one we are going to study how we can convert a lower aldose to higher aldose. Second one, how we can convert a higher aldose to a lower aldose. For example, how we can convert glucose to arabinose. Third one, how we can convert glucose to fructose, an aldohexose to a ketohexose. And fourth one, how we can convert fructose to glucose, an ketohexose to aldohexose. So we will take our first example. We will see how we are going to convert a lower aldose to a higher aldose. That means we are going to convert arabinose to glucose. Arabinose is an aldopentose and glucose is an aldohexose. So the important reaction in this conversion is the Giuliani reaction. That means the arabinose is going to react with HCN. The CN minus attacks the CHO to form a cyanohydrin. And this particular cyanohydrin, this gluconitride, is taken, is separated out, and then on hydrolysis, of course, cyano group on hydrolysis, what do you get? You get COOH group, a carboxy group. So the cyano group is converted to COOH group. And when this compound is heated, a cyclic ester is formed, that is lactone. This particular lactone is formed, which on reduction with sodium amalgam, you get CHO group on the top and the OH group back. So this is the structure of glucose. So from arabinose, you got glucose by treating with first HCN, the Giuliani reaction. You get cyanohydrin or gluconitride, which on hydrolysis you got COOH group, which on heating you got a cyclic ester, that is a lactone, and then which on reduction gave the D plus glucose. So now we will study how we can convert a higher aldose to lower aldose. How we can convert glucose to arabinose. The trick for converting a lower aldose to higher aldose was to introduce a new cyano group and then converting into a carboxylic group and reaction like that. But here, to reduce the number of carbon atom, the carbon atom, a particular carbon atom present in a molecule, you convert to a cyano group and then you eliminate. This is the strategy. So we will see. When you see this scheme, you will understand what I said. You can see glucose on treatment with hydroxylamine. An aldehyde on treatment with hydroxylamine, you get an oxime. So you got glucose on treatment with hydroxylamine, you got this oxime, which on treatment with acetic anhydride, all the OH group will be protected as acetyl, and a dehydration, as the acetic anhydride is a dehydrating agent, so dehydration takes place at the oxime part. You can see the blue H and red NOH. That OH goes as water and that becomes C triple bond N, cyano group. So one carbon atom already present in glucose is converted to CN group. Now if you do a hydrolysis or if you are converting this OAC back to OH group, so all OAC on treatment with the NaOCS3 and in methanol, all OAC is converted to OH group. And the top, the blue color OH group, the OAC becomes OH group that in basic medium that OH becomes C double bond O, and that CN is eliminated to become that CHO. That means that CN, when that CN is eliminated, one carbon atom less aldopentose. So an aldohexose is converted to an aldopentose. First step, this aldohexose is converted to its oxime. Next step, acetic anhydride. This oxime becomes nitrile groups, C triple bond N, and all other OH groups are protected with AC group, acetyl group. And then on treatment with NaOCS3, all OAC becomes OH group, and the last OH group becomes C double bond O, eliminating the CN group to become an aldopentose. Now we will think about the conversion of glucose to fructose. An aldohexose to a ketohexose. Very simple three-step procedure. First you take glucose, you convert to glucosazone. The first step is glucose is converted to glucosazone by the reaction with phenylhydrazine. So you got glucosazone. Glucosazone in acidic medium, in acid hydrolysis, you get that C double bond N becomes CO. So the first CH double bond N becomes CHO, and C6 NHNH2, phenylephrine is gone. And the next one, C double bond N becomes C double bond O. So you get glucosone. Glucosazone on hydrolysis, you get glucosone. Which on reduction with zinc in acetic acid, the CHO group is reduced to CH2OH, which is fructose. Again, just three steps. Glucose is converted to glucosone by treating it with phenylhydrazine. Which on hydrolysis, you get glucosone. Which on reduction with zinc in acetic acid, you get fructose. Okay, now we will come to our last conversion, that is fructose to glucose. A ketohexose to an aldohexose. See the structural difference between fructose and glucose. In fructose, there is a C double bond O group. In glucose, in that place, it is a CHOH group. In fructose, the terminal part is a CH2OH group. In glucose, it is a CHO group. So only in two carbon atoms there is a difference in glucose and fructose. So first we have to change C double bond O in fructose. We are going to change to HOH. So the first step is reduction of the carbonyl group. So hydrogen in presence of nickel, it becomes HOH. We get two products, but we separate sorbitol. So from fructose on reduction with hydrogen in presence of nickel, you get sorbitol. So one part is okay. So now we have to change the terminal CH2OH to CHO group. For that, first we are oxidizing CH2OH to COH group. In presence of HNO3, sorbitol gives gluconic acid. That CH2OH is converted to COH group. That is the second step. Sorbitol on treatment with HNO3, you get gluconic acid. And now the remaining step we have already seen in other conversion. You heat it. When you heat, a cyclic ester is formed, a lactone is formed, which is the gamma lactone of the gluconic acid. You can see it in the scheme. Which on reduction, hydrogen comes on the top and the ring oxygen goes back to its position as OH to get our D plus glucose. Again, fructose reduction, we get sorbitol. Now sorbitol on oxidation with HNO3, the terminal CH2OH becomes COOH group, gluconic acid. Gluconic acid On heating, you get gamma lactone of gluconic acid, which on reduction with sodium amalgam, you get D plus glucose. So these are the important conversions that you have to study in your particular syllabus. First one, a lower aldose to a higher aldose, a higher aldose to a lower aldose, glucose to fructose, and fructose to glucose.